So take down the first problem. So x of t is equal to 2 cos 100 pi t plus 5 sine 50 pi t. Okay, this is the given signal or given equation of x of t. So you have to identify whether the signal is periodic or non-periodic. Okay, if it is periodic, then find the fundamental period t. Okay, so first what will you do? So this is a composite signal. Okay, you don't have only one equation, but you have two equations for a signal. This is called a composite equation or composite signal. So firstly, this is of the form a sin omega t or a cos omega t. Correct? Yes or no?
Yes, ma'am.
So now identify what is omega here. So this is first part of the signal. This is second part. So this is a composite signal, right? You have two types, sine and cos. So we'll take this as one, this as two. So in first part of the signal, what is omega? We'll take it as omega 1. What is omega 1?
100 pi.
Everyone following? Omega 1 is 100 pi. Okay. And what about in second part of the question, what is omega 2?
$50 pi.
50 pi. So now what you have to do is, we know omega is equal to 2 pi f, right? So omega, I'll write 2 pi f1. 2 pi f1 is equal to 100 pi. So now what is f1? 100 pi by 2 pi. So what is your f1? $50, right? So what is t, fundamental period for this 2 cos 100 pi t? 1 by 50 second, correct? Are you guys following?
Yes, ma'am.
Yes, ma'am.
Okay, similarly, we have got what is the fundamental period for this part. Okay, we shall see for this part. Similarly, you have 2 pi f2, which is equal to 50 pi. So what is f2? 50 pi by 2 pi. So what is our f2? It's 25, right? So what is t2? 1 by 25 second, right? So now we have t1 and t2. We have to find the fundamental period for this whole waveform, for this whole equation. We have found out what is the fundamental period for 2 cos 100 pi t as well as 5 sin 50 pi t. Okay, separately we have seen. So if you want to find the fundamental period for this equation, you have to take LCM of t1 and t2. Okay. So fundamental period t is nothing but you have to take LCM of t1 and t2, or you can also take this t1 and t2 in fraction form. So take it in equation form, t1 and t2. So what is t1? You have 1 by 50, whereas t2 you have 1 by 25. So what do you get if you solve this? You get 25 by 50. So what is that? Find the ratio of t1 and t2. It is 1 by 2. So ratio of t1 and t2 is 1 by 2. So t1 by t2 is nothing but 1 by 2. So t1 is equal to, 2 times t1 is equal to t2. This is your fundamental period. So what do you get? So t is equal to 2t1 or t is equal to t2. Fine. Are you guys following? So what is the fundamental period? You can also take LCM of t1 and t2, or you can also take it in ratio. You can take ratio of t1 and t2 to its simplest form, and you can take fundamental period is nothing but 2 times t1 or just t2. So what is our T? 2 times T1 is 1 by 25. Okay, or T2 is nothing but, so T is nothing but T2, which is nothing but 1 by 25. If you take LCM of 1 by 50 and 1 by 25 also, you get 1 by 25 only. Okay, this is your fundamental period. Got it?
Ma'am?
Yes, this is rational number, right? So this is periodic signal because you have got 1 by 50 and 1 by 25 rational. So if you have rational numbers for T1 and T2, then it is a periodic signal, and you can go further and find out the fundamental period. Yes, you have any doubt?
Ma'am, in actually question what we have to find, ma'am? What all things we have to find, ma'am?
They'll tell you to identify whether it's periodic signal or non-periodic signal. And if it's periodic, then find the fundamental period. Clear,
Okay.
everyone? Is it clear? Understood?
Yes, ma'am.
Others followed?
Yes, ma'am.
So what we have, so our equation is given for you. So equation has two types of signals, a cos and sine. You have two parts. It's a composite signal. So imagine this in the form of standard equation, a sin omega t or a cos omega t, and take omega. So this is first part and this is second part. Okay. So in the first part, what is omega? It is 100 pi. In second part, omega is 50 pi. So we know omega is 2 pi f. So I have taken omega 1 as 2 pi f1. Find the frequency f1. Okay, so you get f1 and f2 similarly. So t is nothing but 1 by f, right? So frequency is 1 by time period. So I will take time period. So as you can see here, t1 and t2 both are rational numbers. Okay, so they are periodic. If you have rational numbers, then it's periodic signal. So go ahead and find the fundamental period. So how do we find the fundamental period for t1 and t2? For this equation is you have to take LCM of these t1 and t2. Okay, so or you can also take the ratio of t1 and t2, get the simplest form and equate that. That is your fundamental period. So fundamental period t is nothing but 2 times t1, which is, or it is also equal to t2. Clear, everyone? Is it clear?
Yes.
Others, is it clear?
Yes,
to you?
ma'am.
Okay, we shall see next problem. So here you have x of t is equal to 2 cos 100 pi t plus 5 sine 50 t. Okay, so try to solve in the same way. Okay, this is the first part of the signal, this is the second part of the signal. So what is omega 1? It is 100 pi. And here your omega 2, what is omega 2?
$50, ma'am.
Omega 2 is just 50. Okay, so we can write omega 1 as 2 pi f1, which is equal to 100 pi. So f1 is nothing but 100 pi by 2 pi. So what is f1? It's 50. Correct? So you have 50 here. So time period t1 is equal to 1 by 50 seconds. So similarly here, omega 2 is 50. So what is omega 2? It is 2 pi f2. Okay, it is given to be 50. So try to find f2. It's 50 by 2 pi. So what do you get? If you solve this, you get 25 by pi. Correct? So what is t2 that time? It's pi by 25. Reciprocal of this, right? So now you take the ratio of t1 and t2. Okay, so we don't know it's periodic or non-periodic. So we'll take the ratio of t1 and t2. So ratio of t1 by t2 is nothing but 1 by 50 divided by pi by 25. So what do you get? 25 by 50 pi you get, which is nothing but 1 by 2 pi. So pi is an irrational number. So you have irrational ratio here. So it is a non-periodic signal. Okay, remember, okay. So in previous case, we got a rational number when we took the ratio of T1 and T2, right? So wherever in your question you have, if you come across a problem like this, so if you, in this question, if you have pi form, omega in the form of pi, then that signal will be periodic, okay? So if you have omega as a function of pi, then it's periodic. So if you don't have omega as a function of, if you have omega as a function of integer, here you have 50, right? You don't have pi, then it is non-periodic. Okay, so try to get a difference between both of them. So this is non-periodic, so we'll stop at this stage. We'll not go ahead to find the fundamental period. Clear, everyone?
Yes, ma'am.
Are you following?
Yes, ma'am.
Did you see the difference between both?
Ma'am, in previous question, ma'am, can you show previous question, ma'am?
Yeah.
Ma'am, here if you interchange cos and sine, then T1 and T2 get interchanged only.
What you will interchange?
Show the question, ma'am.
Yeah. It's
Yes.
2 cos 100 pi t plus 5 sine 50 pi t.
Yes, ma'am, actually given. If we write it as 2 sine 100 pi t plus 5 cos omega t, then T1 and T2 get changed, ma'am.
We will see that. We'll try that also. Okay. So your question is, if we have, tell me once again.
2 sine 100 pi t
2 sine 100 pi t
plus 5 cos.
plus 5 cos 50 pi t.
Yes, ma'am.
Okay, so in here, omega, what is omega 1? This is first part, this is second part. So what is omega 1 here? 100 pi. Okay, what is omega 2? It's 50 pi. So 2 pi f1 is equal to 100 pi. So f1 is equal to 100 pi by 2 pi. So f1 is 50. So here 2 pi f2 is equal to 50 pi. So f2 is 50 pi by 2 pi. So f2 is 25. So what is the time period? It's 1 by 50 and 1 by 25. Time period is 1 by 50 seconds and time period 2 is 1 by 25 seconds. So what difference did it make? No difference, right? It's periodic. Got it?
Ma'am, and there they have given like 2 sine and 5 cos, no, ma'am, for starting numbers.
Yeah. Don't worry
Does
about
that-
amplitudes. Don't worry about amplitudes. Just take omega. That's all.
Okay, ma'am.
So if you have omega in the form of, like in the function of, like if you have pi in omega, then it will be periodic only. Okay. So if you have omega as a function of integer, then it's non-periodic, as we saw next case. Don't worry about the amplitudes here. Just check omega. Clear?
Okay, ma'am.
It's the same, no, this problem and this problem. You get same fundamental period. Got it? Followed? You have any doubts still? Whoever asked the doubt, is it clear now?
Yes, ma'am.
Yashas, is it clear?
Yes, ma'am.
So we'll move on to next problem. So take down next problem. So
What does NP mean over there?
non-periodic. Non-periodic signal. So the question will be, I'll write the question, okay, else you will not know what we are doing also. So first identify the signal whether it's periodic or non-periodic. If periodic, find the fundamental period. Okay, first what we are doing is we are finding if the signal is periodic signal or non-periodic signal. Okay, if it's periodic signal, then we are finding the fundamental period. Fine, so take down the question. So x of t is nothing but cos t plus sine root 2t. So try solving this. What is omega? Omega 1, this is first part and this is second part. These are composite signals only. Okay, because you have to cos and sine. Okay, so these are composite signals. So what is omega 1?
1, ma'am.
Omega 1 is 1. So 2 pi f1 is equal to 1. So f1 is 1 by 2 pi. So what is t? It is 2 pi second. Okay, so in second part, omega 2 is root 2. Correct? What is omega 2? It's root 2. So 2 pi f2 is nothing but root 2. So your f2 is nothing but root 2 by 2 pi, which is nothing but 1 by root 2 pi. Correct? So what is your time period? Root 2 pi second. So this is T1 and this is T2. So don't come to conclusion after seeing T1 and T2. So try to take the ratio of T1 and T2. Okay, if you take the ratio of T1 by T2, what do you get? 2 pi by root 2 pi. So what do you get?
Root 2, ma'am.
You get root 2. 1 by root 2. So is it a rational number or irrational number? Sorry, 1 minute. It's root 2.
Ma'am,
Right?
it's just root 2.
Yeah. Yeah, you get root 2. So it's rational or irrational number? It is irrational. Okay, so it is non-periodic signal. Clear, everyone? So by seeing just T1 and T2, don't come to conclusion that it's periodic or non-periodic. Try find the ratio of T1 by T2. Okay, if you get the ratio of T1 by T2 as rational numbers, then it's periodic. If you get irrational numbers, like if you have just pi or root 2, then it's irrational. Then it's non-periodic signal. So no need to find the fundamental period of non-periodic signals. Fine? Clear, everyone?
Yes, ma'am.
So we shall see one more problem. Same question, okay? Identify whether the signal is periodic signal or non-periodic signal. If it's periodic, then find the fundamental period. So x of t is equal to 2 cos t plus 3 cos t by 3. So this is first part of the signal, this is second part of the signal. It's a composite signal. Okay. So now tell me it's a periodic or non-periodic signal. Here omega 1, what is omega 1? In first part?
1, ma'am.
In the second part, what is omega 2?
1 by 3.
1 by 3.
1 by 3. So find the T1 and T2. Okay, 2 pi f1 is 1. So f1 is 1 by 2 pi. So T1 is equal to 2 pi seconds. Similarly, you have 2 pi f2, which is equal to 1 by 3. So f2 is equal to 1 by 6 pi. So T2 is equal to 6 pi seconds. Now find the ratio of T1 and T2.
1 by 3, ma'am.
T1 by T2 is equal to 2 pi by 3 pi, 6 pi. So what do you get? 1 by 3. So it's a rational number, right? So 1 by 3 is a rational number. So the signal is periodic signal. So if the signal is periodic signal, you will find the fundamental period. So tell me the fundamental period for this. How do you calculate the fundamental period? You can take LCM of T1 and T2 to find T. or you can take the ratio, okay, simplest ratio, that is T1 by T2, which is equal to 1 by 3. So T2 is equal to 3T1. So this is your fundamental period. So what is T2? It is 6 pi, which is equal to 3 into 2 pi, which is equal to fundamental period. So fundamental period is equal to 6 pi. Got it? Or you can take LCM also. Clear, everyone?
Yes, ma'am.
Others clear? So after seeing the pi, 2 pi and 6 pi, don't come to conclusion that it's non-periodic signal. So go on and find the ratio of T1 and T2. Okay, if the ratio of T1 and T2 is a rational number, then it's periodic signal. The ratio of T1 and T2 is an irrational number. If you have pi or root 2, something like that, irrational number, so it's non-periodic signal. So if it is periodic, go ahead and find the period, fundamental period. So if it's non-periodic, you can stop there only. Clear?
Yes, ma'am.
Understood? Are you guys solving? I
Yes,
want you
ma'am.
guys to solve with me. You have to solve along with me. Take your time, but you have to solve it. Solve. Okay, am I going fast?
Little.
Okay, we'll go a little bit slow. So take the next problem. X of t is equal to cos square 2 pi t. So this is a given question. Okay. So now we have to find whether the signal is periodic or non-periodic. Find if the signal x of t is periodic or non-periodic. If periodic, find fundamental period. So how will you solve this? So it is cos square theta form, right? So cos square theta, we can write it as 1 plus cos 2 theta by 2. Yes or no? So cos
Yes,
square
ma'am.
theta is equal to 1 by 2 plus cos 2 theta by 2. We'll take in this form. Okay, cos square 2 pi t. So theta is nothing but 2 pi t here. So write in this form. Cos square theta is equal to 1 plus cos 2 theta by 2. So what do you get? What is your x of t? X of t is nothing but 1 plus cos 2 theta. 2 into 2 pi into t. Okay. So you get 4 pi t divided by 2. So you can split this. Okay. You can write it as half plus cos 4 pi t by 2. Fine. So this is your x of t. X of t is half plus cos 4 pi t by 2. So here you have half, right? So that is nothing but DC shift. Okay. It is amplitude factor. It has nothing to do with the fundamental period. Okay. Suppose if you have a cos wave like this. So if you have DC shift of 2, then your signal will be something like this. Got it?
Can you repeat the DC shift part?
Yeah, so you have a fraction here, right? Half plus cos 4 pi t by 2, right? So this half is nothing but its amplitude factor. Okay, it has nothing to do with the fundamental period. So it's nothing but DC shift. So you have a cos 4 pi t, right? Cos wave you have. This is a cos wave. So if you have half plus cos cos function, it will be like this. So if this is a cos function, you have a DC shift of half, the signal will be shifted upwards. Got it? So it has nothing to do with fundamental frequency, fundamental period. So you can go ahead and find the fundamental period for this one. Okay, so what is omega? For this function,
4
what
pi.
is omega? It's 4 pi. Okay, so we can write omega as 2 pi f, which is nothing but 4 pi. So f is nothing but 4 pi by 2 pi, which is nothing but 2. So if frequency is 2, fundamental frequency is 2, then if frequency is 2, time period will be 1 by 2 seconds. Okay, or 0.5 seconds. This is your fundamental period or time period. Clear? Here f is the fundamental frequency or just frequency. Here t is the time period or fundamental period. Clear?
Yes,
Is
ma'am.
it others? Is it clear? Did you follow?
Yes, ma'am.
So if you have cos square theta, write it in the form of 1 plus cos 2 theta by 2. Okay, if you split this, you'll have half plus cos 2 theta by 2. So our theta is 2 pi t here. So 1 plus cos 2 into 2 pi t by 2. Okay, so you get 1 plus cos 4 pi t by 2. Now, similar way I'm splitting this, you get half plus cos 4 pi t by 2. Okay, so this is our x of t. Okay, we have just simplified this using this. So you have half plus cos 4t by 2. So this half is nothing but amplitude factor or DC shift. So it doesn't matter for fundamental period. Okay, so if you have half, it is just DC shift. Okay, it has nothing to do with the fundamental period. So go ahead and find time period for this cos function. Okay, if omega is equal to 2 pi, so you get time period as 0.5 seconds. Omega is 4 pi. Sorry, 2 pi f is equal to 4 pi. So find the fundamental frequency, and from frequency find the fundamental time period. Clear, everyone? So the signal is periodic with the fundamental period 0.5 seconds. Clear, everyone? Understood? So take down next problem. So x of t is equal to e power minus j2t. So what form is this? Exponential. So what form is that? It is e power j theta form, right? So what is e power j theta?
Cos theta plus j sin theta.
Cos theta plus j sin theta. So here you have e power minus j 2t. So how can you elaborate this? So x of t is equal to e power minus j 2t, or you can write cos 2t minus j sin 2t, right? Yes or no? Can we write like this?
Yes, ma'am.
So I'm writing this in the form of e power j theta cos theta plus j sin theta. So you have a question e power minus j 2t. So it's of the form e power j theta. Okay, it's nothing but cos theta plus j sin theta. So now you write this in cos theta plus j sin theta form. So you have got this. So now this is a composite signal, right? It's of two. The signal is of two parts, cos form and sin form. So what is omega 1? This is first part and this is second part. What is omega 1?
2, ma'am.
What is omega 2?
2, ma'am. Minus 2, ma'am.
Just 2. Omega 2. Okay, this is omega. Okay, so find whether the signal is
Ma'am, that
periodic or
coefficient J
non-periodic.
doesn't matter.
No, just take omega. We are taking just omega 1 and omega 2,
Ma'am,
that's all.
Ma'am, then what is that J over there?
It's imaginary value, right? J. Imaginary part.
Oh, okay. Oh, so we only consider the omega part, which
Yeah,
is
you have a signal A sine omega t or A cos omega t. We are interested in only omega here. Okay, we don't care about amplitude or sine or anything. Okay, just check omega. What is omega? And go ahead and solve the problem. Clear?
yes, ma'am.
So 2 pi f1 is equal to 2. So what is f1? 2 by 2 pi. So it is 1 by pi. So what is time period? It is pi seconds. So don't judge here only that it's not non-periodic. Just you have to find the ratio of T1 and T2. So T1 is pi seconds. We'll see what is T2. Okay, so you have 2 pi f2, which is nothing but 2. So f2 is also 2 by 2 pi, which is equal to 1 by pi. So what is T2? It is also pi seconds. So what is the ratio of T1 by T2? It is pi seconds by pi seconds, which is equal to 1. So 1 is a rational number, so this is a periodic signal. Fine. 1 is a rational number. So what is the time period for this? Sorry, fundamental period for this?
1, ma'am.
Yeah, 1. So T1 is T1 by T2 is equal to 1. So T1 is equal to T2 is equal to T. Okay, it is 1. Clear? Understood?
Yes, ma'am.
How to find whether the signal is periodic or non-periodic? Did you understand?
Ma'am, isn't it pi?
LCM of pi and pi. What is LCM
Not
of?
the LCM, ma'am, the fundamental period.
LCM of T1 and T2. What is that?
1.
One minute. Yeah, it's equal to pi. So it's pi. Okay, fundamental period is equal to pi. Fine. So if you take LCM of pi and pi, 1 and 1 you get. So LCM of T1 and T2 is pi. Okay. So if you take the ratio also, T1 by T2 is equal to 1, right? So T1 is equal to T2 is equal to capital T, which is nothing but pi. Okay. I'm sorry, the fundamental period is pi, not 1.
Ma'am, but in this method, what we have done, we have got 1, no, ma'am.
Which method?
Like pi by pi, it gets cancelled and we'll get
No,
1, no,
no.
ma'am.
This is just ratio. That's all. T1 by T2 is equal to ratio. This is just to check whether it's periodic or non-periodic. That's all. You have got 1, right?
Ma'am, so to find
Okay,
the fundamental period, we have to always take the LCM of the two
LCM
time
of
periods,
T1
right?
and T2, or you can also take T1 by T2 is equal to 1, right? So T1 is equal to T2, which is equal to fundamental period T. So what is T1 or T2? It is pi seconds, right? So fundamental period is also pi seconds. Got it?
Yes,
Okay.
ma'am.
Understood? Is it clear?
Yes,
Is
ma'am.
it clear, guys? So I'll explain you once again. So we have a problem. We have a signal x of t of e power j theta form. Okay, so we have written it in the form cos theta plus j sin theta. So cos 2t minus j sin 2t. Okay, e power minus j theta is nothing but cos theta minus j sin theta. Okay, this is of this form problem. So find, this is a composite signal. You have to find omega 1 and omega 2. Okay, if you have just a single term, then you can just find omega. Okay, but here we have two parts in the question, right? So find omega 1 and omega 2. So omega 1 is 2 and omega 2 is also 2. So we'll write omega in the form of 2 pi f. Okay, so 2 pi f is equal to 2. So what is f or 2 pi f1 is equal to 2? F1 is nothing but 1 by pi. So if f1 is 1 by pi, then time period t1 is nothing but pi seconds, right? It's reciprocal of frequency. Similarly, 2 pi f2 is 2. So f2 is 2 by 2 pi or 1 by pi. So t2 is also pi seconds. Okay. So to find whether it's periodic or non-periodic, we take the ratio of t1 and t2. Okay. Let us be clear. So to find whether it's periodic or non-periodic, take the ratio of t1 and t2. So ratio of t1 and t2 is 1. It's a rational number. Okay. If it's rational, then the signal is periodic. Okay. The signal is periodic. Now we'll go ahead to find the fundamental period. Okay. How do we find the fundamental period? T, capital T. Capital T, we represent it as fundamental period. So fundamental period is nothing but it's LCM of T1 and T2. T1 and T2. Okay, don't get confused. It's LCM of T1 and T2. So what is LCM of T1 and T2? We get pi. So time period is equal to pi seconds. Fundamental period is nothing but pi seconds. Clear? Or you have one more method to find, if you can't find LCM, you have the ratio of T1 by T2, right? So it is equal to 1. So T1 is equal to T2, which is equal to time period. So what is T1? T1 is pi seconds, which is equal to T2 is also pi seconds, is nothing but fundamental period. Got it? Clear, everyone?
Yes, ma'am.
Understood?
Yes, ma'am.
Okay, so we shall see one more problem. So what we are doing is only continuous time signals. Okay, we didn't go to discrete time signals yet. So we shall see that also. First we'll complete continuous time signals, finding the fundamental period or identifying whether it's periodic or non-periodic. So take the next problem. We'll take discrete time signal now. Okay, so next problem. We have x of n is equal to cos pi n by phi into sine pi n by 3. Okay, so what do you have here? X of n. Wait, I'll take a normal signal first, then I'll take composite signal. So x of n is equal to, you take this, cos 0.01 pi n. Check whether the given signal is periodic or non-periodic. If it's periodic, then find the fundamental period. Okay. So what is omega here? This is discrete signal. Okay, this is not continuous time signal. Continuous time signal will be in the form of x of t. This is continuous time signal. This is a discrete time signal. Okay, discrete time signal. So what is x of n? So what is your omega here?
0.01 pi.
So omega we represent like this in discrete time. It is 0.01 pi. Yes or no? So we know that omega is 2 pi by n. So if we have omega as 0.01 pi. So try to express this as 2 pi by n into m form. Okay, so how do you express this to 2 pi into m by n form?
Ma'am, is it 2 pi into 1 by n?
So wait, you have omega 0.01 pi. So I'm telling you to express this omega in 2 pi into m by n form. Here m and n are integers. How will you express this in 2 pi into m by n form? Multiply and divide by 2. Should we multiply and divide it by 2? So omega is nothing but I'll multiply and divide by 2. Okay, 0.01 divided by 2. I've just rearranged it. Okay, I'll write if you want 0.01 pi into 2 by 2. That I've rearranged like this. I've written 2 pi into 0.01 by 2. Yes or no? Can we write like this? Why are you guys silent?
Yes, ma'am, we can write.
Following? Are you guys following? So I have
Yes.
got omega. This is my omega, right? So I'm taking omega in this form, 2 pi into m by n form, where m and n are integers. Okay, so to find the fundamental period n, now I'm trying to get that in this form, 2 pi into m by n form. So I multiply and divide by the numerator and denominator by 2. Okay, so I'll rearrange this like this. Okay, so I want my m to be integer. So what can I do? So 2 pi into 1 divided by 200, correct?
Ma'am, can you repeat the previous step, ma'am?
Yeah.
Why we are dividing it by 2 only, ma'am?
If you want to express this 0.01 in 2 pi into m by n form, you have to multiply and divide it by 2, right? You are converting this form to this form. You are trying to express this omega in this form. Clear? We have 0.01 pi, correct? Omega, according to this question.
Yes, ma'am.
We are trying
Yes,
to
ma'am.
express omega in this form. Omega is nothing but 2 pi into small m divided by n, where your small m and n are integers. If I want to
Yes,
express this in this form, I have to multiply and divide it by 2, right? So I
Okay,
have
ma'am,
just
I got it.
rearranged this. I have just rearranged this to write 2 pi into 0.01 by 2.
Okay, ma'am.
So what is the condition here? M and n should be integers, right? So it is 2 pi into 1 divided by 2 into, shall I write 0.01 as 100, 1 by 100. So what is my n here? So I get 2 pi into 1 divided by 200. Now I have expressed this 0.01 pi in the form of 2 pi into m by n form. Yes or no? So what is small m here? It is 1. And what is capital N, fundamental period? It is 200 samples. Understood? This is of the
Yes,
form
ma'am.
2 pi into m by n. So my n is nothing but 200 samples. Clear? Is it clear?
Yes, ma'am.
Everyone? So when you can't express this in this form, then it is non-periodic. Okay, you can stop at that stage. Clear? Did you understand this problem? We'll solve more problems and you'll get more clarity. Okay, in discrete time signals, we take omega and try to express it in 2 pi into m by n form. Okay, where m and n are integers. So what have we done here? We have 0.01 pi. So to express that in 2 pi into m by n form, I am multiplying and dividing the numerator and denominator by 2. Fine. So I am rearranging this. I want in the form 2 pi by n into m form. So I can write it as 2 pi by 2 into 0.01. This 0.01 I can write it as 1 by 100, right? So I've written as 1 by 100. So I have achieved, right? I want omega in this form and I've got that in this form. So I get 2 pi into 1 by 200. See here, my m and n are integers. Got it? This is N and this is M. So my N is 200 samples. Is it clear?
Ma'am,
Yes.
ma'am, in this question, just we have to find the n value, no, ma'am. Samples we have to find, no, ma'am.
Fundamental period for discrete time signal.
Ma'am, as we can do it in the same procedure as we done previously, no, ma'am. Like 2 pi by n, we can take that formula and do, no, ma'am.
You can do like that also, but this is
We
more
get to
easier.
same answer.
Yeah, this is more easier than that.
Okay, ma'am.
Okay, sometimes you might go wrong if you do like that. You can do like that also, but this is the standard form. Try to get it in the form 2 pi by n into m.
Okay, ma'am.
Clear, everyone? Is it clear?
Ma'am, how do we say whether it's periodic or non-periodic with this?
So here we have got that we are trying to express this omega in this form, right?
Yes, ma'am.
In some problems you cannot express this in this form. You will not get m and n as m or n as integers. That time it's non-periodic. Okay, I will show that example also. This is clear now. So this signal is periodic.
Ma'am, why did we make m as from 0.01 to 1, ma'am?
I can write 0.01 as 1 by 100, right?
Yes, ma'am.
So I've just done that to get it in this form. The condition is m and n should be integers. Now I have a possibility, right? I can make it. I can convert this 0.01 as 1 by 100, right? Instead of keeping like that only, I want it in integer form, m and n. So I've just modified this. 1 by 100 I have written instead of 0.01. Both are same, right?
Okay. Good.
That's all. So your signal cos 0.01 pi n is periodic with 200 samples, with n is equal to 200 samples. Okay. So take down this. X of n is equal to cos 3 pi n. Try solving this. So tell me, it's periodic or non-periodic? Try solving. What is omega? What is omega?
3 pi.
Omega is 3 pi. So I will express this omega in this form. 2 pi by n into m form, where m and n are integers. Try expressing that in that form. To express this 3 pi in 2 pi by n into m form, you have to multiply and divide it by 2. Okay. So 3 pi into 2 divided by 2. Now you rearrange that. You get 2 pi into 3 by 2. Have I got it in this form? Standard form?
Yes, ma'am.
Right? I have 3 and 2 integers. N and m are integers. So what is my fundamental period? N.
2.
N is 2 samples. Clear? Is it clear, students?
Ma'am, is there any significance of m, ma'am?
No, that is just to get your fundamental period. We use this. Okay? So m might be anything.
Okay, ma'am.
But it should be an integer. M and n should be integer. You have to get your omega in this form. You can play around that, okay? You can just.
Can you tell once more why we take n? Why we divided by 2, ma'am? Can you tell once more?
Yeah. So in this question, you have cos 3 pi n. That is your x of n. It is a discrete time signal, right? So what is omega here? We represent omega like this in the discrete time signals. Okay, omega is nothing but 3 pi. So this I have to represent in this form, omega 2 pi by n into m. So how do I convert this 3 pi to this form? How can I express this in this form, omega in this form? I can multiply and divide by 2, right? So this 3 pi I'll multiply by 2 and divide by 2. Numerator and denominator I'll multiply and divide by 2. So I'll rearrange this so that I'll get 2 pi into 3 by 2. Have I expressed this in this form, standard form? We have
Yes, ma'am.
expressed,
Got
right?
it.
So we
Yes,
have
ma'am.
expressed that just rearranging and keeping that in 2 pi by n into m form, where m and n are integers. Okay, so you have n as 2 samples. Clear? Take next
Yes,
problem. X of n is equal to sine 3n. Do this. Find if it's periodic or non-periodic, and if it's periodic, find the fundamental period n. This is a discrete time signal. So what is omega?
3.
Omega is 3. Okay, so now you have got omega 3. Try expressing that in the form of 2 pi by n into m form, where m and n are integers. So to express this in this form, express this 3 in this form, what will you do?
Multiply and divide by 2 pi.
2
Yeah.
pi.
Multiply and divide by 2 pi. 2 pi into 3 divided by 2 pi. So what do you get? 2 pi
N is equal to 2 pi samples.
by 2 pi. What is our condition here? M and n should be integers. Okay, our m is an integer. Is an n integer? It's not an integer.
Rational.
Yeah, it's not an integer. So it's non-periodic signals. Understood?
Yes, ma'am.
Do you follow now?
Yes, ma'am.
Yes, ma'am.
So if you have omega in the function in the form of pi, then the signals will be periodic. Correct? So what can you conclude from this? If you have omega in the function in the form of pi, then the signal is periodic signal, right? Previous was periodic signal. Periodic with n is equal to 2 samples. But if you have omega as a function of an integer, okay? So if you have omega as a function of an integer, then the signal is non-periodic. Got it? Is it clear?
Yes, ma'am.
Everyone, is it clear? I just meant to say that if you have omega as a function of pi, then your signal will be periodic. If you have omega as a just an integer, then it will be non-periodic. Clear? Is it clear, everyone? See, here
Yes, ma'am.
we try to express this in 2 pi by n into m form, so that we multiply and divide it by 2 pi. So what did we get? We got m to be an integer, but n is not an integer, right? So it's non-periodic. For this discrete time signal to be periodic, both m and n should be integers when you express it in 2 pi by n into m form. Clear, everyone? Shall we move to next problem? Clear?
Yes, ma'am.
Okay, so take down next problem. X of n is equal to sine 2 pi by 5 into n plus cos 2 pi by 7 into n. So this is a composite discrete time signal. You have to identify what type of signal is that. It's a composite discrete time signal. Why discrete time signal? Because you have x of n. Okay, why it's composite? Because it's consisting of two functions, sine function and cos function. Okay, sine function and cos function. So it's composite. You have addition of two functions here. Hence it's a composite signal. Now how we have seen in discrete time, continuous time signal, similar way you try solving this. So what is omega 1?
2 pi by 5.
Omega 1 is 2 pi by 5. And what is omega 2? 2 pi by 7. Correct? Now try expressing this omega 1 and omega 2 in 2 pi by n into m form, where your m and n are integers. Okay? So try expressing that and tell me what is n1 and n2.
Ma'am, N1 is 5 samples, ma'am.
Yes. What is n2? So
N2 is 7 samples.
yes. So I want to express this in the form 2 pi by n into m. So omega 1 is equal to 2 pi into 1 by 5. I have got this in this form. Okay, 2 pi by n into m, where m and n are integers. M is 1 and n1. We'll take it as n1 because we have two functions, right? So omega 1 I'll try to express in the form 2 pi into m by n1. Okay, whereas omega 2 I'll try to express in the form same 2 pi into m by n2. Omega 2. So omega 2 will be 2 pi into 1 by 7. As you can see in both the cases, your m is an integer and n1 and n2 are also integers. Okay, from this you can write n1 is equal to 5 samples and n2 is equal to 7 samples. Right? So what is your fundamental period n? So how did we do in continuous time signals? We found the ratio of n1 by n2, right? Sorry, t1 by t2. Similarly, find the ratio of n1 by n2. So what do you get? Pi by 7, right? So 5 by 7 is a rational number. It's a periodic signal. Okay, now find the fundamental period. So if you have
35.
Yeah, it's 35 samples. So if you have the ratio of n1 by n2 in the form of root 2 or pi, then it's irrational and non-periodic. So here we have 5 by 7, it's a rational number. So you can go ahead and find the fundamental period. So you can take fundamental period n as the LCM of n1 and n2. Okay, so LCM of 5 and 7 is 35, right? LCM of 5 and 7 is 35, right? So 35 samples. Or you can also do this way also. You can equate n1 and n2. n1 into 7 is equal to n2 into 5 is your fundamental period n. Okay. So n1 is 5 into 7, you get 35, or you can take 7 into 5, n2 into 5, it is 35 samples. Okay, a fundamental period n is equal to 35 samples. Is it clear? Is it clear, guys?
Yes, ma'am.
Yes, ma'am.
Following? I'll just brief up this problem. So we have a composite discrete time signal. Okay, you have a sine term, sine function and cos function. So what is omega 1? Omega 1 is 2 pi by 5, whereas omega 2 is 2 pi by 7. So now try to express this 2 pi by 5 and 2 pi by 7 in the form 2 pi by n into m, where m and n are integers. Okay, so directly we can do, no need to multiply with 2 pi or 2 or divide by 2, directly we'll get it. 2 pi into 1 by 5 is in this form, right? 2 pi by n into m form, where m and n are integers. So directly we'll get this. So n has 5 samples and n1 has 5 samples and n2 has 7 samples. Now we have to find the ratio. of n1 by n2 to find whether it's periodic or non-periodic. Okay, so if we take 5 ratio of n1 by n2, so you get a rational number, or directly here also you'll get to know that it's periodic, right? You have to get m and n as integers, then it will be periodic only. So just one more step, we are just verifying. N1 by N2 is 5 by 7, it's rational. So you can go ahead and find the fundamental period N. So N is nothing but LCM of N1 and N2, LCM of 5 and 7, you get it at 35 samples. Or you can also take the ratio, equate it, N1 into 7, which is equal to N2 into 5 is nothing but your fundamental period N. Okay, so you get 35 samples. So you can do any method. Okay, I'm teaching you both the methods. Clear, everyone? Is it clear or not? Are you guys solving?
Yes, ma'am. Clear.
Are you guys solving? Or just you're seeing?
Yes, ma'am.
What about others?
You're
Yes,
solving it.
ma'am.
Are you getting enough time to solve?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now we'll move on to next problem. Take down this problem. So x of n is equal to cos pi n by 5 into sin pi n by 3. So what type of signal is this? You have x of n as discrete time signal. It's a product of two signals, right? It's product of cos and sine. So it is of the form cos A sin B. Correct? So you have to get it in the form, you have to have addition of two signals. Okay, you cannot write omega 1 and omega 2, that will be wrong. Okay, so this is of the form cos A sin B, or we can arrange it in the form of sin A cos B. Okay, I will take sin pi n by 3 into cos pi n by 5. So now it is of the form sin A cos B.
Yes, ma'am.
What is the formula for sin A cos B?
1 by 2 sin A plus B by 2 plus sin A minus B by 2.
Half sin A plus B plus sin A minus B. Okay.
Yes, ma'am.
Now try getting this in this form. This x of n, try to get it in this form. Okay, because if you have multiplication of two signals or product of two signals, you cannot directly solve for omega 1 and omega 2. That will be wrong. Okay, you have to get it in the form of addition of two signals, composite signal. Okay, so try to get it in this form, and later we'll try to solve omega 1 and omega 2. So it's half sine, what is A? Pi by 3 plus B is pi by 5 into n plus sine pi by 3 minus pi by 5 into n. What do you get? X of n. Tell me what you get. Take LCM here. Okay, you get 15 here. So pi by 3 into 15, you get 5 pi plus 3 pi. Okay, so that will be 8 pi by 15. Half sine 8 pi by 15 n plus sine, what do you get here? Pi by 3 into 15, you get
2 pi by 3.
Yeah, you will get pi by 3 into 15 will be 5 pi minus 3 pi, right? Pi by 5 into 15. You get 3 pi. 3 is a. So if you solve that, you get 5 pi minus 3 pi by 15. It will be 2 pi by 15n. Got it? Everyone, did you get it in this form?
Yes, ma'am.
Now we have got the signal in composite form. Don't worry about this half. Okay. So we have got it in composite form. This is first part of the signal, the second part of the signal. Okay, this is 1 and this is 2. Now go ahead and find omega 1 and omega 2. Or n1 and n2. So what do you get? Omega 1, what is omega 1? This is first part of the signal, the second part of the signal. After you get it, if you have in addition formula, you can go ahead and solve for n1 and n2. If you have multiplication like this, you have to convert that into some form. Okay, using the formula sin A cos B. You cannot directly do omega 1 and omega 2 here only. Okay, that will be wrong. After getting it into some form, then you have to go ahead and find n1 and n2. Okay, clear? Are you guys there?
Yes, ma'am.
Yes, ma'am.
Are you solving?
Yes, ma'am.
So what is omega 1? It's 8 pi by 15 and omega 2 is 2 pi by 15. Now try to get it in the form. How do you express this? Try to get it in the form. Omega is equal to 2 pi into m by n. So what you have? Omega 1 is equal to 2 pi into 4 by 15 and omega 2 is 2 pi into 1 by 15. We have got it in this form, right? Omega 1 and omega 2. Clear? Respond, guys. Why are you silent?
Yes, ma'am.
We have got omega 1 and omega 2 in this form. 2 pi by n into m form. Here also we have got 2 pi into m by n form. 2 pi into m by n form. So what is our n1 and n2? What is n1?
15.
15.
N2?
15.
Yeah. Now
15,
we
ma'am.
have the ratio
N is
of
equal to
n is LCM of n1 and n2. Okay.
15.
So
N is
that
equal to
is the
15.
ratio. N1 by n2 is equal to 15 by 15, which is equal to 1. 1 is a rational number, so it's periodic. It's rational, so it's periodic signal. So now find the fundamental period. LCM of 15 comma 15, or sorry, n1 comma n2. So that would be 15 only. Okay, or you can also do like this. N1 by n2 is equal to 1. Okay, I'm expressing this n1 is equal to n2, which is equal to n, fundamental period. So my n is equal to 15. Because n1 is also 15, n2 is also 15 samples. So fundamental period n is equal to 15 samples. Clear?
Yes,
Clear,
ma'am.
everyone? Are you guys following? Periodic, non-periodic signal
ma'am.
with respect to continuous time and discrete time. Clear?
Yes, ma'am.
Are you guys solving?
Yes, ma'am.
What about others?
Solving.
Vinay, you are solving? Vinay is not there. So we'll go to next problem. Try this one. So x of n is equal to cos n by 8 into cos n pi by 8. Here you have multiplication of signals. So I'll teach you a trick directly. So I have told you if your omega is a function of pi, it's periodic. If it's not, it's a function of an integer, then it's non-periodic. So this is a non-periodic signal and this is a periodic signal. Okay. So the product of periodic signal and non-periodic signal will be a non-periodic signal only. Okay. I'll write it. Product of periodic and non-periodic signal is a non-periodic signal only. Okay, you can stop at this stage. Fine. So take down this one. Sine. Okay. Take down next problem. X of n is equal to sine pi plus 0.2 n. Try this. It's periodic or non-periodic. So in this function, you have phase shift of pi. Okay. Here the phase shift is pi here. It is of the form sine omega t plus phi. Correct? So what you do is, you can ignore this phi and go ahead and find omega. So what is omega? It's 0.2. So it's periodic or non-periodic?
Non-periodic.
It's non-periodic. Okay, you don't have a function of pi in omega. Correct? So the signal will be likely non-periodic only. Okay? So I cannot represent that in the form of 2 pi into m by n. Okay, so it is non-periodic signal. And take down this problem. You can solve it or you can take it like that only. Take down this one, next problem. So x of n is equal to e power j pi by 4 n. So it is of the form e power j theta, which is nothing but cos theta plus j sin theta. Correct? Now you solve it. Try to get it in cos theta plus j sin theta form. So what is theta? It is pi by 4. So what do you get? Cos pi by 4 into n plus j sin pi by 4 into n. So we have got addition of two signals, and go ahead and find out the fundamental period. This is a discrete time signal. So find out what is omega 1, what is omega 2, and find out the fundamental period. Try this.
Ma'am, n is equal to 8, ma'am.
Yes. What did you get? N1, N2?
N1 is also
8,
8 and N2 is also 8, ma'am.
Yes. So omega 1 is pi by 4 and omega 2 is also pi by 4. Okay. So omega 1 and omega 2 I'll try to express in the form 2 pi into m by n. So 2 pi. So I have to multiply and divide it by 2, right? So 2 pi into 1 by 8. Omega 2 is 2 pi into 1 by 8. Okay. So you get N1 and N2 as 8 only. My N1 is equal to 8 and N2 is also equal to 8. So the LCM of N1 and N2 is 8. So N is equal to 8 samples. Clear?
yes, ma'am.
Try this problem. X of t, this is continuous time problem. Okay. X of t is equal to sine square 4 pi t. Try this. So you have sine square theta. So how will we represent this? We'll try to represent this as 1 minus, yes?
1 minus cos square theta by 2.
Yeah, this is of the form sine square theta. We'll express this in the form 1 minus cos 2 theta by 2. Split that 1 by 2 minus cos 2 theta by 2. Okay, theta here is 4 pi t. So you can write this as x of t will be, I'll take half minus cos 2 into 4 pi t. It's 8 pi t by 2. Correct? It's correct, guys?
Yes, ma'am.
Yeah. Now we have x of t half minus cos 8 pi t by 2. So this half is DC value. Or what is this? It's DC value or amplitude, right? So it doesn't have anything to do with fundamental period. So calculate the fundamental period for this cos 8 pi t by 2.
Ma'am, n is equal to 1, ma'am.
This is continuous time signal.
Correct, ma'am. I got it.
T, omega you take like this. Omega naught is equal. What is omega naught? What is omega naught?
Eight pi, ma'am.
8 pi. Omega naught is equal to 8 pi. So take 2 pi f naught. We are expressing omega as 2 pi f. Correct? So 2 pi f naught is equal to 8 pi. Or your fundamental frequency is nothing but 4.
4, ma'am.
So what is fundamental period?
1 by 4 seconds.
Yes, it's 1 by 4 seconds or 0.25 seconds. Clear, guys?
Yes, ma'am.
Clear?
Yes,
Everyone?
ma'am.
Are you guys solving with me?
Yes, ma'am.
So this is one example of continuous time. So I'll give you one more example of continuous time only. So we have solved 4 types, right? A single term with continuous time, and 2 terms, whereas discrete time also single term and 2 terms. Okay, this is all about periodic and non-periodic. Okay, you'll have problems compulsorily, okay, from unit 1, periodic or non-periodic signal. So you have to solve like this. So take down next problem. X of t is sine 6 pi t plus cos 5 pi t. Okay, in textbook it might be confusing. Okay, different textbooks will use different methods, but I have taught you the easiest method, both in continuous and discrete. Okay, so you have a next question. X of t is sine 6 pi t plus cos 5 pi t. So this is a composite signal, as you all can see. So this is first part of the signal, this is second part of the signal. So try to find omega 1 and omega 2. So what is omega 1?
Six pi, ma'am.
6 pi, omega 2, 5 pi. So 2 pi, after you get what is omega, take omega in the form 2 pi f. Okay. Whereas in discrete time we are taking omega and we are trying to express that in the form of 2 pi by n into m in discrete time. Whereas in continuous time, omega is nothing but 2 pi f. From that f you will get t. Here from this you will get n. Okay. To summarize this, you can make note of this somewhere. So 2 pi f1 is nothing but 6 pi. So f1 is nothing but 3. So t1 is 1 by 3. Okay. So this we haven't come across such problem. See, your time period t1 is in the ratio form 1 by 3. Okay. So you have 2 pi f2, which is nothing but 5 pi. So f2 is 5 by 2. Correct? So your t2 will be 2 by 5. So first you'll take the ratio of t1 and t2. Okay, obviously it's periodic signal only. T1 by t2 is 1 by 3 divided by 2 by 5. Okay, you get 5 by 6. So 5 by 6 is a rational number, so it's a periodic signal. So now go ahead and find the LCM of T1 and T2. Okay, so how do you find the LCM of fractions like this?
Ma'am, t is equals to 2.
T1, so T is nothing but LCM of T1 and T2. Yeah, T is equal to 2, correct. So our T is LCM of 1 by 3 and 2 by 5. So how do you find LCM of these fractions? How do you find LCM of fractions? Or you can use this method also. T1 into 6 is equal to 5 into T2. That is your fundamental period. So T1 into 1 by, T1 is 1 by 3, no? 1 by 3 into 6 is equal to 5 into 2 by 5. So you get 2. T is equal to 2 seconds, right? Which is equal to 2 seconds. You have got like this. So if you have LCM of fractions, how you will solve? Could anyone tell me how will you solve LCM of fractions?
Ma'am, it's 1 by 3 into 1 by 5 into 2, ma'am.
1 by 3 into 1 by 5
Into 2.
How you got 1 by 5 into 2? So how will we get LCM here? No, it is not like that. So if you have LCM of fractions, so what you have to do is you have to take LCM of numerator by HCF of denominator. So what is LCM of numerator? 1, 2, what is the LCM? And HCF of 3, 5. LCM is least common multiple. Okay, so what is LCM of 1 and 2? It's 2. And what is HCF? Highest common factor. What is that? 3 and 5? It's 1, right? So the time period is 2 seconds. Clear? You can do any method, okay? Just for extra information, I have done this. You can do this method also. Whichever is easy, you do that. Clear?
Yes, ma'am.
Everyone, is it clear?
Yes, ma'am.
Yes, ma'am.
So I'll give you some problems. You try solving this, and we'll wind up this class after solving these 3 problems. Okay. So next class I'll do deterministic signal and random signal. So take down next problem. So take x of n is equal to e power j to n. First problem. You try this and tell me the answer. If you didn't get, I'll solve it. X of n is equal to cos 3 pi by 4 n. And third one, it's sine 3 pi by 4 n plus cos 5 pi by 7 n. Try solving this. You have to do this by yourself. I have given you 3 problems. Try doing this.
Ma'am, for second one, n is equal to 8 samples.
Yes, n is equal to 8 samples. So how do you get? Omega naught is equal to 3 pi by 4. So I'll try to express this in the form. Omega is 2 pi by n into m form. So
Ma'am, first one is non-periodic function, ma'am.
yes, it's non-periodic. This is non-periodic signal or function. Okay, here we are trying to express omega as 2 pi by n into m. So omega is nothing but I'll multiply and divide by 2. Okay, so 3 pi by 4 into 2 by 2. Okay, so now I have 2 pi into 3 by 8. So n is equal to 8. What about third one?
Ma'am, n is equals to 16.
Third one.
Ma'am, n is equals to 16.
60 or 16.
16, ma'am.
No, try again. Third one, you try this. You not get 16. 3 pi by 4 and 5 pi by 7. Yes. See, omega 1 is 3 pi by 4 and omega 2 is 5 pi by 7. Correct. Now try to express this in this form. 2 pi by n into m. Multiply and divide by 2 for both the functions. You multiply and divide
56.
by 2. Yes, it's 56. So we'll try to express omega 1 in 2 pi by m, 2 pi by n into m, and omega 2 also as 2 pi by n into m. So I have 3 pi by 4 and 5 pi by 7. I can, to get 2 pi, I want 2 here, right? 2 pi. So I have to multiply and divide by 2. 3 pi by 4 into 2, multiply and divide by 2, numerator and denominator. Here also. Omega 2 also, you do 5 pi by 7 into 2 divided by 2. Okay, so what do you get? I'll rearrange that. So I'll get 2 pi into 3 by 8. So 2 pi into 3 by 8. And this is omega 1, and omega 2 is 2 pi into 5 by 14. So my n1 is 8, n2 is 14. Now take for LCM of n1 and n2. LCM of 8 comma 4, what do you get? Sorry, 8 comma 14. 2 4s are 2 7s are. So 7 2s are 14. 14 into 4, you get 56. Or if you find, you can do a ratio of n1 by n2. If you take that 8 by 14, you will get. So 4 by 7. So n1 into 7 is equal to n2 into 4. That is equal to n. N is equal to n1 into 7, which is equal to n2 into 4. So what is n1? 8 into 7, which is equal to, what is n2? 14 into 4. You get 56 is equal to 56. That is your fundamental period, 56 samples. Clear?
Yes, ma'am.
Everyone, is it clear?
Yes, ma'am.
Did everyone solve this?
Yes, ma'am.
Yes, ma'am.
Are you able to solve? So we have discussed about non-periodic and periodic signals in detail. Okay, I have solved all the type of problems. So non-periodic and periodic. We have seen with respect to continuous time and discrete time. Okay, single value function as well as composite signals. Okay. So next topic is different classification of signals. Okay, deterministic and random signals. So just you have to know what is deterministic signal and what is random signal, that's all. So you don't have any problems on this. Just you have to know what is deterministic signal and what is random signal. After this, we have even signal and odd signal. Here you have problems, even and odd signals. Okay, you have problems with respect to waveforms also, signals also. So, and tomorrow I have an exam test duty. So I'll start a little bit late. I'll start at 10:20. Okay, so I think I can do this now. Deterministic and random signal. I'll just explain you what it is. Okay, because tomorrow I have till 10:15 I have test duty of 6th semester students. Okay, so I'll just explain you what is deterministic and random, and tomorrow I'll do even and odd. Okay, if that duty gets over early, then I'll take class. Okay, so it will be only for small amount of time. So tomorrow I'll do even and odd. Just today I'll do deterministic signal and random. I'll just explain you what that is. That is enough for you. You don't have any problems on that. So deterministic signal can be represented in the as a function of time. Okay, so the behavior of these deterministic signals is predictable with respect to time. Okay, if I tell you x of t is equal to cos 4 pi t or sine 6 pi t. So in deterministic signals, you have time given. Okay, so in deterministic signals, you will have a time function. Okay, so you can find that signal at any point of time if you know what is the value of t. Okay, so they can be represented as a function of time. So deterministic signal can be represented as a function of time, and they are predictable. Okay, with respect to time. These are deterministic signals. Coming to random signals, so these are unpredictable signals. So for example, outcome of a toss of a coin. You don't know, right? And your ECG signal, you cannot predict, right? And noise from amplifiers. like noise from amplifier of radio receiver. Okay, noise from electronic components. So these are all random signals. Okay, outcome of a toss of a coin, ECG signal, noise from electronic components. You cannot predict at what time how much you get. Okay, so for deterministic signal, given the value of time, you can obtain the exact value of a signal. Okay, that is about deterministic signal and random signal. Okay, just you have to know what is deterministic signal and what is random signal. So random signal are not predictable. Okay, for example, like outcome of a toss of a coin, ECG signal, or noise from electronic components. Fine. So deterministic signal is a function of time. You can represent deterministic signal as a function of time. Okay, and behavior of these signal is predictable at any instant of time. Okay, given the value of time, if I give you the value of time, you can obtain the value of a signal, right? But here it cannot be represented as a function of time. Okay, that is about deterministic signal and random signals. Clear? Understood?
Yes, ma'am.
Is it clear, everyone? So next class, I'll do even signal and odd signals. Fine. So I'll take the attendance. Vinay is there?
Yes, ma'am, present.
Vinayak Rao?
Yes, ma'am.
Sorry. I have to take two. Vinayak Rao? Vishal?
Yes, ma'am.
Yash?
Present, ma'am.
Yashas?
Present, ma'am.
Yashwant?
Ma'am.
Yashwant is there?
Vishal present, ma'am.
Vishal present. Yashwant? Absent. Zenith? Absent. Zilvayu?
Yes, ma'am.
How do you pronounce your name?
Zivilo.
Zivilo. Okay, I'm sorry.
Yeah.
Srishti? Sohan? Sohan is present. Tejas J. Vijay?
Yes, ma'am.
Vilohit? Absent. Vinamrata?
Present, ma'am.
Vineet? Absent. Vineet M? Abhishek? Abhishek is absent. Ajay Lokesh?
Present, ma'am.
Akash Bharadwaj? Absent. Kulsum?
Present, ma'am.
Maithili?
Present, ma'am.
Actually, you are present, right? Okay. Rushingwa? Not there. He's there.
Present.
Satvik? Sorry. Rushingwa is there, right?
Present, ma'am.
Satvik?
Present, ma'am.
Prashank?
Present, ma'am.
Srijani? Srijani is not there. Dilsha Hamad? Absent. Ajay? What happened to this guy? Hills? Rohit Adhikari?
Yes, ma'am.
Vivek? Pratiksha,
Present, ma'am.
Rahul Dinesh, Bharat RV,
Present, ma'am.
Bhavika,
Yes, ma'am.
Vaishnavi,
Present, ma'am.
Ahalya,
Present, ma'am.
Manjunath. Manjunath is there?
Present, Present, present.
Okay.
Manjunath, present.
Okay, madam. Veena,
Present, ma'am.
Rakshita,
Present, ma'am.
Kiran H,
Present, ma'am.
Akshay,
Present, ma'am.
Hanumanta,
Present, ma'am.
Girish,
Present,
Girish
ma'am.
Kumar,
Present, ma'am.
Pavan Kumar,
Present, ma'am.
Sumalata,
Present, ma'am.
Mamata Shri,
Present, ma'am.
Praveen,
Present, ma'am.
Nikita, Nikita, Mohan,
Present, ma'am.
Chetana,
Present.
Chetana is there?
Present.
Kiran Kumar,
Present, ma'am.
Gautam,
Present, ma'am.
okay guys, we'll
Ma'am,
continue
ma'am,
class.
ma'am, 186.
What were you doing when I
Ma'am, I
called
was in
you?
wash. I'd been to washroom.
Okay. H1. Okay, guys, we'll continue in tomorrow's class. Okay, tomorrow I'll start late. I'll start at 10:20. Okay, because I have test duty. Thank you, students.
Ma'am, share the video, ma'am.
Thank you, ma'am.
Yeah, I'll share the recording.
Ma'am, if you're not free, you can take it on Saturday so that tomorrow many teachers are not taking, so I can just cancel all the classes.
Is it? Okay, Saturday also I have exam duty, test duty. Saturday, what time you are free?
We are free from, if you have test duty from 12:10 till like 1 o'clock, what is that? 2 o'clock you can take. No,
I have morning 9 to 10:15 Saturday.
12:10 to you're not free, ma'am, till 1:10.
I'm free that time.
Then you can take that time, ma'am.